Hello students, welcome to our live APS classes, and as all we know that this is our foundation course especially for the students from 9 to 12. And in our today's live lecture we will start with our new chapter, that is chapter number 5 for class 12, and the name of the chapter is surface chemistry. And regarding this chapter today we will discuss important 25 questions from this chapter. So first of all, welcome to all the students who joined with us our live APS classes, and this is the syllabus for the term 1 examination that is to be held in November 2021. So before starting this chapter, that is the surface chemistry, let us give us a brief introduction from this chapter. And your surface chemistry is that branch of chemistry which deals with the study of the phenomenon that occurring at the surface or interference that is at the boundary separating two bulk phases. The two bulk phases can be pure compound or solution. So this is the brief introduction for the chapter that is the surface chemistry. Now let us start our first question from this chapter, and your first question is volume of 1 mole of any gas at NTP is, options are A 11.2 liter, B 22.4 liter, C 10.2 liter, and D is 22.8 liter. So volume of 1 mole of any gas at NTP, that is normal temperature and pressure. So the volume of 1 mole of gas is either 11.2 liter, 22.4 liter, 10.2 liter, and 22.8 liter. That means out of these four options, which is the volume of 1 mole of any gas at normal temperature and pressure? So the volume of 1 mole of any gas at normal temperature and pressure is 22.4 liter. So this is the volume of 1 mole of any gas at normal temperature and pressure, that is 22.4 liter. So this is the right answer for the question number 1. That is 22.4 liter. This is the volume of 1 mole of any gas, and that is at NTP. And NTP is the normal temperature and pressure. Now shift to the question number 2, and your question number 2 is Tyndall effect confirms the, option A is gravity effect on the soul particles, light scattering by the soul particles, heterogeneous nature of the soul, and D is the Brownian motion of the soul particles. That means Tyndall effect confirms out of these four factors, which is the most important factor that confirms the Tyndall effect. That is the gravity effect on the soul particles, light scattering by the soul particles, heterogeneous nature of the soul particles, as well as Brownian motion of the soul particles. So here beta Tyndall effect confirms the heterogeneous nature of the soul. Heterogeneous nature of souls. So here Tyndall effect confirms the heterogeneous nature of the souls, not gravity effect on the soul particles, not the light scattering by the soul particles. उनको भी वो confirm नहीं करता है Tyndall effect जो होता है, even not Brownian motion of the soul particles. तो ये सारे factors जो है इनको Tyndall effect confirm नहीं करता है, but only the Tyndall effect confirms the heterogeneous nature of the souls. So here this is the right answer, that is the heterogeneous nature of the souls. So here Tyndall effect only confirms the heterogeneous nature of the souls. Next is your question number 3, and your question number 3 is which one of the following is aliophilic colloid? Options are milk, gum, fog, and blood. So out of these, which one of the following is the aliophilic colloid? And it is your question number 3. Aliophilic colloid means that colloid that is not properly mixing. So here the aliophilic colloid. Aliophilic colloid is the gum. Not the milk, not the fog, and not the blood. But aliophilic colloid is the gum. This is the The right answer, that is the alveolar colloid, is the gum. Question number 4. Which of the following is not correct for the enzyme catalysis? Options are: enzyme activity is maximum at optimum pH, that is between 5 to 7. B. Each enzyme is specific for a given reaction. C. The favorable temperature range of the enzyme activity is between 25 to 37 degrees Celsius. And D is the enzymatic activity is increased in the presence of certain substances that are called as coenzymes. So out of these, which is not correct for the enzyme catalysis? Last one is the enzymatic activity is increased in the presence of certain substances, and these certain substances are called as the coenzymes. So out of these, which is not correct for the enzyme catalysis? Enzyme catalysis. And it is the question number 4. So beta, out of these, that is not correct for the enzyme catalysis is the favorable temperature. Favorable temperature, and that favorable temperature range of enzyme activity is between, that enzyme activity is between 25 to 37 degrees Celsius. So this is not correct for the enzyme catalysis. That is, the favorable temperature range of the enzyme activity is between 25 degrees Celsius to 37 degrees Celsius. This is not correct for the enzyme catalysis. So here this is the right answer. That is, the favorable temperature range of the enzyme activity is between 25 degrees Celsius to 37 degrees Celsius. Next is the question number 5. Presence of traces of arsenic oxide, that is AS2O3, in the reacting gases SO2, that is sulfur dioxide, and O3, that is ozone, in the presence of platinized asbestos in contact process, act as either catalytic promoter, catalytic poison, dehydrating agent, and the drying agent. It is the question number 5. Presence of traces of arsenic oxide, that is AS2O3, in the reacting gases, that is sulfur dioxide and ozone, in the presence of platinized asbestos in contact process, and they act as either catalytic promoter, catalytic poison, dehydrating agent, and the drying agent. So which is the right answer for the question number 5? So with the presence of traces of the arsenic oxide, that is AS2O3, in the reacting gases, that is sulfur dioxide and ozone, in the presence of platinized asbestos in contact process, they act as a catalytic poison. Catalytic poison. So here option B is the right answer for the question number 5. That is catalytic poison, not catalytic promoter, not dehydrating agent, and even not drying agent. Question number 6. Shape selective catalysis is reaction catalyzed by. Shape selective catalysis is a reaction catalyzed by. Options are zeolites, B enzymes, C platinum, and D is Ziegler-Natta catalyst. So which is the right option regarding the shape selective catalysis is a reaction, and that is catalyzed by either zeolites, enzymes, platinum, and Ziegler-Natta catalyst. So here the shape selective catalysis is a reaction, and it is catalyzed by zeolites. Zeolite. So this is the shape selective catalysis and is a reaction that is catalyzed by zeolite. Not enzyme, not platinum, and not Ziegler-Natta catalyst. It is your question number 6. So zeolite is the right answer. Next is your question number 7. And your question number 7 is Which of the following types of metal make the most efficient catalyst? Which of the following types of metals make the most efficient catalyst? Options are alkali metals, transition metals, inner transition metals, and alkaline earth metals. That means you have to choose out of these following types of the metals, and that metals makes the most efficient catalyst. Either the options are alkali metals, transition metals, inner transition metals, and alkaline earth metals. So only the transition metals, only the transition metals are the types of the metals that makes the most efficient catalyst. So here this is the right answer, that is the transition metals are the metals that makes the most efficient catalyst. Next is the question number 8. The oxide of nitrogen which act as a catalyst in lead chamber processes. Options are NO, B NO2, C N2O4, and D is H2O5. The oxide of nitrogen which act as a catalyst in lead chamber processes. It is the question number 8. The oxide of nitrogen which act as a catalyst in lead chamber. So the oxide of nitrogen that acts as a catalyst in the lead chamber process is NO, that is nitrous oxide. Nitrous oxide is the oxide of nitrogen that act as a catalyst, especially in the lead chamber. So here this is the right answer, that is nitrous oxide is the only oxide of nitrogen that act as the catalyst in the chamber of the in lead chamber process. Next is your question number 9, and your question number 9 is the activity of an enzyme becomes ineffective. The activity of an enzyme becomes ineffective. Option A is at low temperature, B at atmospheric pressure, C at high temperature, and D is in aqueous medium. So which is the type of the activity of an enzyme where it becomes ineffective? Either at low temperature, at atmospheric pressure, at high temperature, and in aqueous medium. So where the activity of the enzymes become ineffective? The activity of an enzymes, तो बच्चे जो enzymes की activity है वो एक ही condition पर ineffective होती है जब वो high temperature उसके ऊपर apply किया जाता है, at high temperature. So it is the condition that is the high temperature, and the high temperature the activity of an enzyme becomes ineffective. So this is the condition where the activity of an enzyme becomes ineffective. That is the at high temperature, not at low temperature, not at atmospheric pressure, and even not in aqueous mediums, but only at high temperature the activity of an enzyme becomes ineffective. So this is the right answer. Next is the question number 10. Which of the following can absorb larger volume of hydrogen gas? Out of these, you have to choose which absorb larger volume of the hydrogen gas. Options are finely divided platinum, B colloidal solution of palladium, C small pieces of palladium, and D is a single metal surface of platinum. So which of the following can absorb larger volume of the hydrogen gas? Either finely divided platinum, colloidal solution of palladium, small pieces of palladium, and a single metal surface of the platinum. It is your question number 10. So out of these, which can absorb a larger volume of the hydrogen gas is the colloidal solution of palladium. Colloidal solution of palladium. So this is the condition where it can absorb larger volume of the hydrogen gas, and that is a colloidal solution of the palladium. It can absorb larger volume of the hydrogen gas. So this is the right answer. Colloidal solution of the palladium. It can absorb larger volume of the hydrogen gas. Next is your question number 11, and your question number 11 is which of the following gases present in polluted areas will be absorbed most easily on the charcoal gas mask? Option are H2, O3, N2, and SO2. So, out of these following gases that are specially present in the polluted areas and they will absorb most easily on the charcoal gas. So, which is the gas? H2, O3, N2 and SO2. So SO2 is the gas that is present in the polluted areas and it will absorb most easily on the charcoal gas, that is sulfur dioxide. Sulfur dioxide. So this is the right answer. So here option D is the right answer for the question number 11. Next is the question number 12. Which kind of catalysis can be explained on the basis of adsorption theory? Which kind of catalysis can be explained on the basis of adsorption theory? Options are homogeneous catalysis, heterogeneous catalysis, negative catalysis, and autocatalysis. So, which kind of catalysis can be obtained on the basis of the adsorption theory? So, especially on the basis of the adsorption theory, which kind of catalysis can be explained especially on the basis of the adsorption theory? Either homogeneous catalysis, heterogeneous catalysis, negative catalysis, and autocatalysis. So heterogeneous catalysis. Heterogeneous catalysis. Heterogeneous catalysis are the catalysis that can be explained on the basis of the adsorption theory. So here this is the right answer, that is the heterogeneous catalysis. Next is your question number 13, and your question number 13 is a colloidal system in which liquid is dispersed phase and solid is dispersion medium is classified as. A colloidal system in which liquid is dispersed phase and solid is dispersion medium is classified as. Option A is gel, B sol, C emulsion, and D is aerosol. So here a colloidal system in which the liquid is dispersed phase and solid is dispersion medium is classified as either the gel, sol, emulsion, and aerosol. So here the colloidal system in which the liquid is dispersed phase and solid is dispersion medium is classified as gel, where the liquid is the dispersed phase and solid is in the dispersion medium, that is classified as gel. So here this is the right answer. Next is your question number 14, and your question number 14 is which of the following will not confirm a colloidal system? Options are solid gas, B liquid gas, C gas, and D is gas liquid. So which of the following will not form a colloidal system? It is the question number 14. इनमें से कौन है जो कि कोलाइडल सिस्टम को फॉर्म नहीं करता है? सॉलिड गैसेस जो होते हैं वो ऑलमोस्ट कोलाइडल सिस्टम को परफॉर्म करते हैं. लिक्विड गैस जो होता है वो भी कोलाइडल सिस्टम को फॉर्म करता है. इवन गैस एंड लिक्विड जो होते हैं वो भी कोलाइडल सिस्टम को फॉर्म करते हैं. बट गैस will not form a colloidal system. Form a colloidal system. So here this is the right answer, that is the gas will not form the colloidal system. Question number 15. Fog is an example of the colloidal system of liquid in gas, gas in liquid, solid in gas, and gas in solid. Fog is an example of the colloidal system of either liquid in gas, gas in liquid, solid in gas, and gas in solid. So, which is the example of fog? Fog is an example of colloidal system of. 4 options are there. Question number 15. So fog is an example of the colloidal system of liquid in gas. Liquid in gas. So fog is an example of the colloidal system of liquid and gas. So here this is the right answer, not gas and liquid, not solid and gas, not gas and solid, but liquid and gas. It is the example of fog of the colloidal system. Next is the question number 16. Substances which behave as normal electrolyte solutions at low concentration and exhibit colloids properties at higher concentration are called as, options are lyophilic colloids, B, lyophobic colloids, C, macromolecular colloids, and D is associated colloids. Substances which behave as the normal electrolyte solutions at low concentration and exhibit colloids properties at higher concentration are called as either the lyophilic colloids, lyophobic colloids, macromolecular colloids, as well as associated colloids. So the substances that behave as the normal electrolyte solutions at low concentration and they exhibit the properties of the higher concentration, they are called as associated colloids. Associated colloids. They are called as associated colloids. Not macromolecular colloids, not lyophilic colloids, and even not lyophobic colloids. But these are the examples of the associated colloids. Next is your question number 17. Which of the following act as the best coagulating agent for the ferric hydroxide sole? Options are potassium ferrocyanide, B, potassium chloride, C, potassium oxalate, and D is aluminum chloride. Which of the following act as the best coagulating agent for the ferric hydroxide sole? Potassium ferrocyanide, potassium chloride, potassium oxalate, as well as aluminum chloride. So out of these, that act as the best coagulating agent for the ferric hydroxide sole is potassium ferrocyanide. Potassium ferrocyanide. This is the best coagulating agent for the ferric hydroxide sole, that is the potassium ferrocyanide. So here this is the right answer. Next is the question number 18. The formation of missiles takes place only above. Option is critical temperature, B, Kraft temperature, C, inversion temperature, and D is the absolute temperature. So the formation of missiles takes place only above. The formation of missiles takes place only above either critical temperature, Kraft temperature, inversion temperature, and absolute temperature. So the formation of missiles takes place only above the Kraft temperature. Kraft temperature. So this is the right answer. That is, the formation of the missiles takes place only above the Kraft temperature, not above the critical temperature, not above the inversion temperature, and even not the absolute temperature. But the formation of missiles takes place only above the Kraft temperature. Next is the question number 19. The size of the colloidal particles ranges between 10 raised to power 7 to 10 raised to power 8 centimeter, 10 raised to power 9 to 10 raised to power 11 centimeter, 10 raised to power 4 to 10 raised to power 7 centimeter, and the last is 10 raised to power 2 to 10 raised to power 3 centimeter. So what is the size of the colloidal particles that ranges between? And that the size of the colloidal particles, it always ranges between, जो size होता है colloidal particles का, it always ranges between 10 raised to power 4 to 10 raised to power 7 centimeter. इसके बीच में हमेशा जो साइज होता है colloidal particles का वो रेंज करता है, एंड दैट साइज जो रेंज करता है colloidal particles का वो है between 10 raised to power 4 to 10 raised to power 7 centimeter. So this is the right answer. Next is your question number 20. And your question number 20 is HCMC, that is the critical missile concentration. The surface molecules, option A is dissociates, B associates, C become bigger in size due to adsorption, and D is become smaller in size due to decomposition. So at critical missile concentration, the surface molecules are dissociates, associates, become bigger in size due to adsorption, and become smaller in size due to decomposition. At CMC, that is a critical missile concentration, the surface molecules associate. The surface molecules always associate, not dissociates, not becomes bigger in size due to adsorption, and not becomes smaller in size due to decomposition. But at CMC, the surface molecules always associate. So this is the right answer. Next is your question number 21, and your question number 21 is, which of the following is not a method for the coagulation of lyophobic soil? Which of the following is not a method for the coagulation of lyophobic soils? Options are by electroforces, B by mixing oppositely charged soils, C by adding electrolyte, and D is by adding a protective colloid. So which of the following is not a method for the coagulation of lyophobic soils? इनमें से कौन सा ऐसा मेथड है that is not used for the coagulation of the lyophobic soils? तो इलेक्ट्रोफोर्सेस जो है वो भी ज्यादातर कोगुलेशन ऑफ लायोफोबिक सोल्स के लिए यूज होता है, मिक्सिंग ऑपोजिटली चार्ज सोल्स भी यूज होते हैं, एडिंग इलेक्ट्रोलाइट भी यूज होते हैं कोगुलेशन ऑफ लायोफोबिक सोल्स के लिए, बट बाय एडिंग अ प्रोटेक्टिव कोलाइड, एडिंग ए protective colloid is not a method for the coagulation of the lyophobic soil. So this is the right answer, that is by adding a protective colloid. Is a method is not a method for the coagulation of the lyophobic soils. Next is your question number 22. Why is alum added to water containing suspended impurities? Why alum is added to water containing suspended impurities? Options are to make a colloidal solution, B to coagulate the suspended impurities, C to remove the impurities of calcium and magnesium, and D is to protect the colloidal solutions from getting precipitated. So why is alum added to water containing suspended impurities? So alum is added to water containing suspended impurities to coagulate the suspended impurities. To coagulate the suspended impurities. So alum is added to water that containing suspended impurities to coagulate the suspended impurities. To coagulate the suspended impurities. So that's why alum is added to water that containing the suspended impurities. Next is the question number 23. Movement of dispersion medium under the influence of electric field is known as electrodialysis, electroforces, electroosmosis, and capture-osis. Cata-forces, not capture forces, but cata-forces. So movement of the dispersion medium under the influence of the electric field is known as either electrodialysis, electroforces, electroosmosis, as well as cata-forces. So the movement of dispersion medium under the influence of the electric field is known as, that is electroosmosis. Electroosmosis. So the movement of the dispersion medium under the influence of the electric field is known as electroosmosis, not electrodialysis, not electroforces, and even not cata-forces. So here this is the right answer, that is electroosmosis. Next is the question number 24. Which of the following is not a method of removing impurities from a colloidal soil? Options are electrodialysis, ultrafiltration, ultracentrifugation, and distillation. So which of the following is not a method for removing impurities from the colloidal soil? So out of these, the method that is not used for removing the impurities from the colloidal sole is the distillation. So distillation is the method that is not used for removing impurities from the colloidal sole. So here this is the right answer for the question number 24. And it is our last question for our today's live video lecture, that is your question number 25. And your question number 25 is the substances which behave as the colloidal solutions at higher concentration. They are called as associated colloids, B, multi-molecular colloids, C, macromolecular colloids, and D is protective colloids. So the substances that behave as both colloidal solutions and they are act as the colloidal solutions at higher concentration, they are called as either the associated colloids, multi-molecular colloids, macromolecular colloids, as well as protective colloids. So the substances that behave as the colloidal solutions, especially at higher concentration, they are called as associated colloids. They are called as associated colloids. So here this is the right answer for the question number 25, that is the associated colloids. So here beta, this is all about this chapter, that is the surface chemistry, and this is chapter number 5. And regarding this chapter, today we will discuss important 25 MCQ questions or objective questions from this chapter. कल बेटे हम आपके साथ एक नई वीडियो में एक नए चैप्टर के साथ और नए ऑब्जेक्टिव क्वेश्चंस के साथ दोबारा मिलेंगे. So once again, good night to all the students who joined with us our live APS classes.